Okay, gentlemen and ladies, good morning, good afternoon, good afternoon. How are we doing, please? I hope everybody's doing very well. Okay, welcome once again. Today we are going to look at something very exciting. I'm so happy we are getting to the end of the whole thing, and I'm hoping that you are grabbing something for your lessons in programming in the coming semesters, okay? Now, we will begin today by looking at an important concept called arrays. Okay, so we'll look at arrays, what they are. We'll declare an array. By declare, I mean create an array, put something into the array. Then we will indicate or help us to understand the kinds of array we can have. And then we'll use loops. Remember loops? Last week we did the lecture on loops. So use loops to process arrays. Okay, we'll process single dimensional and then two-dimensional arrays. And then eventually we will end the lecture by looking at the advantages of using arrays. Why arrays are important to us in programming. Okay. So let's proceed. Now, when we say an array, what is an array? An array is very simple. It's simply a collection of variables, okay, of the same type with the same name. Okay, remember, if you create a variable int I equal to 0, what it means is that you can only put one item inside that box I, and that item must be an integer. You recall. Now, what if I wanted or I asked you to create 50 or 300 or 1,000 variables? Okay, it will be very difficult for you to create 50 or 300 or 1,000 variables. Okay, it's very difficult. Okay, so in order to do that very easily, what arrays are is that arrays allow you to create multiple memory containers or containers for storing things, all with the same name. Okay, so an array is just a simple way of creating multiple locations with one name. Okay, so one container, one variable, one container, one variable, but with an array, one array, many variables or many containers. Okay, so but the important thing to note is that all the arrays have the same name, right? The array will have all the containers inside the array will have the same name, and they must all have the same data type. You cannot create a container for storing names and then you put people's phone numbers inside. No. If it is for storing names, it can only hold names. If it is for storing phone numbers, it can only hold phone numbers. It cannot hold names and phone numbers at the same time. That's what an array is. An array is a data type for or a collection of variables or collection of values for storing multiple values with the same name that have the same data type. Okay, that's what an array basically is. Now, the way we have, when we say, okay, so if you have multiple containers which have the same name, how do you differentiate the first one from the second one and the third one? Because the first one is called X, second one is also called X, third one is called X, fourth one is called X, all the way to the last one, they are all called X. But how do you tell which one is X number 1 and which one is X number 2 and X number 3 and so on and so forth? So what we do to separate or to define or to distinguish one array from the other is to use something we call subscript or index. The index is a number that indicates the position. So we can say that in an array, maybe we have an item at position, the first position, we'll call it X at position 0, okay? Then the second one will be X position 1, okay? Or X index 2, or X index 3, and so on and so forth. So in this depiction, you can see it clearly down here. Okay, when we create an array, there will be space for storing the data, but there's also space for giving the computer a way to identify one value from another value. Okay, so the array has a way for differentiating or from distinguishing one value from another value. Now, when you create an array, one will ask, okay, so how do I create an array? In order to create an array, you need to determine what type of information am I storing. Okay, so I say that, oh, I'm creating an array for storing my, the amount of money I make, okay? So, or the prices of items in my shop. So maybe the array I declare an array, money is in decimals. So I declare an array and I call this one prices. Then you need to tell the computer the size of the array. So I say that, oh, in my shop, I have 10 items I want to sell in my shop. So I have 10 items I want to sell in my shop. So the size of that array is 10. So that is how, or this is how you create or you declare an array of size 10. Okay. Now, when you create or you declare an array of size 10, what will happen is that the computer will look for space where it can store all the 10 items together and label each item according to the position or the index. Now, the computer starts labeling them from 0. Okay, so please take note of that. The computer starts labeling them from, even though 0 is the first item label, even though the first item label is 0, right? We label them from 0. I mean, we label them from 0. Okay. Any questions? Any questions? Can you hear me?
Sir, we can hear you.
Okay, and you are clear with what I said?
Sir, for me, I just joined. So
okay, you let me continue. Let me continue. Okay, so we now know that if we want to create an array, all we need to do is to ask ourselves what data type or what type should we store in the array. If we are storing integers, then we will need to just write, declare, let me undo. Okay, so we need to just write declare, okay, then write the int, then the name of the array, let's call this one amount, and then we indicate the size of the array. And what the computer will do is to look for empty space that can store 1,000 things and then label it from 0 all the way. Because we are starting from 0, the last number will be 999. Okay? Because it's always going to be the size minus 1. Okay? Because we start numbering from 0. Okay? And all of them are going to be called amounts. Okay, so if all of them are called amounts, how do we differentiate them? We differentiate them using the index. So we know that this one is amount at position 0, amount at position 1, amount at 2, amount at 3, so on and so forth. Okay. So I have some examples. So over here, when I create an array of 5 things, remember this array is called num. And this array is an integer array. The size is 5. What it means is that the first item position is position 0. Second item position is position 1. Third position is 2, 3, and then 4. Notice that even though we said that the size, so even though we said that the size is 5, because we start numbering from 0, the last number is 4. Okay, so it means here, even though we said 10, because we start numbering from 0, because we start numbering from 0, the next one will be 1, will be 2, and then the last number will be 9, because 0 to 9 are 10 numbers. Here, the first one is 0. We go all the way to what? 119, because the last one should be from 0 to 119 will give us 120. Then to 25, we have 0 all the way to what? 24. Because 0 to 24 is 25 numbers. Okay? Okay. Now, let's put something into an array. So somebody asks, okay, so how do I put something inside an array? If I create an array, let's say an example, an array, I declare an array, an integer array called num. I tell the computer it has 5 things. Now, the computer has created 5 empty spaces. 1, 2. Okay. With each one having a particular index. Okay. And all of them are called num. Okay. Now, how do I put things inside? We call it initialization. Okay. So how do you initialize? You have to call the array name and then do the index and then put the value inside. So an example is what I have stated over here. You see the examples over here. So if, for example, if I do num at index 0 is equal to 10, then what it means is that 10 has been put inside the first location. If I do num at index 1, I do equal to 11, it means, it means 11 has been put into that location. If I do num index 2 equal to 12, it means 12 has been put into that location. If I do num 3 equal to 13, it means 13 has been put into that location. Then finally, if I do num 4 equal 14, it means 14 has been put into that location. So however or whichever variable or array you create, if you want to put something inside, you can assign the thing one by one like this using the index. So you write the array name, you write the index, and then you write the value of the value that you want to put at that location or that position.
Hello, sir.
Now, yes, sir. Yes, sir.
So please, for in this, how do you call it? In this array initialization, it should be something accordingly by the value in the position, isn't it?
Come again.
I said in this array initialization, it should be something accordingly to the value in the positions, isn't it? Because you said,
not necessarily. You mean you go from 0 to 1 to 2 to 3? Is that what you mean?
Yes, sir. So like,
you can do whichever one you want.
Okay.
You can do 1 first, then do 0, then do 5, then do 3, then do 2. The computer can deal with all of that. It doesn't really need you to start from 1 all the time and end at maybe the last one. No.
Okay. All right. Thank you.
Okay. So, for example, if you create an array, if we create an array called maybe float price, okay? We say price contains maybe 4 things, okay? And then we say that, okay, price at position 2 is equal to 2.4. And maybe we say, price at position let's say 4. Oh, sorry, there's no position 4 because it's the last number is 4. So it will be 0 to 3, okay? So maybe price at position 0 is equal to 7.1, okay? And we can stop. What it means is that the computer will still create space for all the 4 things, okay? But we have only set the value of position 2, which is what? 2.4. Remember, the first one is 0, second one is 1, third one is 2, and then the last one is what? 3. Okay, and then the one at position is 7.1. Okay, the rest of these ones can be empty. It's perfectly understandable. Are you with me? Is this
Yes,
what
sir.
you were asking about or something else?
Yeah, it was this.
Yeah. And it's not by force to start from 0 all the time and end at the last number. No, it's not by force. Okay.
Oh, okay.
Okay.
Yeah, thank you.
You're welcome, sir. Okay. So any other question? You can just raise your hand or you can shoot. I'll listen. Now, what if you want to how do you call it? Enter the items all together. You don't want to enter it. You don't want to enter the items one by one, like you are seeing over here. Okay. Maybe you want to enter. You have the items in a bracket, and you want to enter them. So another way to do initialization is to enter the items together. Okay. And how do you enter the items together? You write the array name with the index, and then you set the value of the array. Okay, using the curly brackets. Okay, so an example is like, for example, over here we created the array called items, and then we put the things inside as we were creating it. Notice that over here we didn't write the size of the array. Okay, but we advise you to always write the size of the array. Okay, it's very important. As for array, you must write the size. If you don't write the size, what the computer will do is to count the size and initialize the size for you, which may not necessarily be a good thing. Okay, so please take note of that. Okay, and another example, we have declared an array called names. The data type is what? String, and we are putting the names Kwame, Kofi, Ama, and Efia inside. You could have also decided to just write names, and then at position 0, you could have decided to put Kwame, and then at sorry. Oh, where is that? Okay. Oh, I think I missed. Sorry, I think I missed the slide. Okay. But you can also put them in one by one yourself, or you can put them in together like how you are seeing over here. Okay. Then somebody will ask, okay, so how do I access the things that are inside an array? If there are something inside an array, how do I access or ask the computer to show me what is inside the array? Okay, you can do it one by one, or you can do it together. Now, if you want to do it one by one, how do you do it? All you need to know is the name of the array and then the position or the index of the array. So, for example, if I have an array called num, and I've already put something inside now, maybe I have the items 2, 5, 7, and 9 inside num. Okay, let's make sure that it's an integer. Then the moment I do num at position maybe 0, 1, 2, num at position 2, what will be printed on the screen is this. Remember, this one is 0, this is 1, this is 2, this is 3. So position 2, you get what? 7. If I do write num at position maybe 0, I'm going to get what? 2. If I do num at position 3, I am going to get what? 9. So that is what, or how the computer is going to see the items and allow you to print what is inside a particular position. So here in this example, I have an array called sales, and I have some values inside that array. And I've indicated the index or the position. Okay. So these ones are index or position. Now, if I do sales at position 0, it will print 12.5 because of this. If I do the next one, it will print 8.25 because of this. If I do the next one, it will print 25.00 because of this. This one will also this. Then the next one will print this because when I do that one, then this one will also print this because when I do this, and then last and finally, we will see this one as well. Is it understood, please?
Yes, sir.
Okay, so the items, you can print them based on the index. Okay? Very, very important. Now, there are basically two main kinds of arrays, okay? Two main kinds. We have what we call single dimensional and multi-dimensional, okay? But under multi-dimensional, we have been writing multi-dimensional for so long that one of them has become very popular in our modern day computing, okay? Programming. So that one is a two-dimensional. Okay, so we can have two-dimensional, one-dimensional, and multi-dimensional. Okay, one-dimensional means that we are working with vectors, okay? If either a transpose vector or a horizontal vector, and then or a vertical vector or horizontal vector. And then two-dimensional means that we are dealing with a matrix, okay? Matrix, two-dimensional, where we have rows and columns, okay? Then multi-dimensional means that we could be dealing with a three-dimensional figure, okay? Sorry. So this could be multi-dimensional set of values, okay? Are we okay?
Yes, sir.
Okay. Now, how do we process? Processing here has to do with what? What are the basic operations we can do with single dimensional or one dimensional array? What are the basic operations? So you can decide that, oh, as for me, I want to see the items one by one. In that case, you will simply write the name of the array and write the position of the item that you want to see. Okay. But in a case where you want to print or see everything, then how do you go about it? You can use a loop. And the best loop or the loops that you can use include what? The for loop, the while loop, and the do while loop. Okay. Last week's lecture looked at loops. So if you don't understand anything, go back to the video, go back to the slides, ask a question in the discussion and then or the forum, and then we'll all answer you. Now, to process a one-dimensional, to go through all the elements of a one-dimensional array, you can simply use as a for loop, a counter-controlled for loop, where you indicate the start as 0 and then the limit or the end condition as the size of the array. So for example, if I create an array called num, and I declare that num is maybe 100 items, then over here, I need to make sure that I end at 100. So I end at from 0 to 999, okay? Notice that you must always start from 0 because loops always start from 0. Okay, please take note that you must start from 0 because loops always start from 0. So you must also start from 0. But the end of the loop is always going to be written as j or I less than 100 because less than the size of the loop, because for the loop, we don't get to the last number. We always get to the number before the last number because we start counting from 0. Now, we can write the same thing we wrote using a while loop. Okay, so notice that for the for loop, this part goes up here, this part condition goes in here, and then this last part goes down here. Okay, so take note of that. Now, for example, if I ask you to write statements to print everything in a loop, okay, so here the you can write that, okay, for the loop, you start from 0, and then maybe if 10 is the size of the loop, then you want to make sure that you don't get to 10. So you get to int less than 10. So it means that the last number will be 9. Okay. Then because loops start from 0 and we go to 1 and we go to 2 and then we go all the way to 9, we are increasing +1 +1. So you can do index plus plus. Index plus plus will cause the loop to loop until it gets to 1. Are you with me? Hello?
Yes, sir.
Okay, please, if anyone has any questions, you let me know, okay?
Yeah, follow me, sir.
Okay, that's good, that's good. So over here, we want to allow the user to enter something at the keyboard, okay? So we do input and then sales, and then you put the index in. So remember, the index will change from, when we start, say index is 0, okay? So you see sales at position 0, okay? Then when we do +1, remember index plus plus means we are doing index is equal to index plus 1, okay? So please remember that that is equal to index plus 1. So you do sales at position 1, because then next time you come, you do +1, then you do sales at position 2. It's only index that will change. It's not that index is changing, because 2 is less than 10. Then you do sales index at position 3 because 3 is less than 10. Then you do sales index at position 4 because 4 is less than 10. Then you do sales index at position 5 because 5 is less than 10. Then you do sales position 6, sales position 7, sales position 8, sales position 9. Now notice that we will stop at 9 because the next time we run, remember 10 is not less than 10. Okay, so because 10 is not less than 10, you need to stop at 9. 0 to 9 are 10 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you stop at 9. Any questions about this? Hello?
Yes, sir.
Are we still here on the
Yes,
call?
sir.
Are we on the call?
Yes, sir.
Yeah, what will be the end while for the distance for the flows?
Oh, it is just the end. I'm just indicating the end. You move it. It's not anything relevant. Okay, it's just pseudocode.
Okay, thank you.
Okay. Okay. So here too, same thing, but here I'm setting the value to 0. So if I have this correctly, okay, 1, 2, 3, 4, 5, 2, 3, 4. Okay. So the first one be 0, 0.0, 0, 0.0, 0, 0.0, 0, 0.0, 0.0. Remember, we are just setting 0, 0.0, okay? 0, 0.0, 0, 0.0, 0, 0.0, 0, 0.0, 0, 0.0, and then 0, 0.0. Remember, they are all called what? Sales. But we can differentiate them based on the index. Okay? 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Okay, this is not part. Okay, so it means the last one is 9/8. Okay. Okay, so basically what I have, the gentleman was asking about the while. What I have is that every time I write with a for loop, I also write with a while loop, just to show you that you can also do it with a while loop. Okay. Hello.
Yes, sir.
Are you following?
Okay, sir.
Yes.
So just to show you that you can do it with a while loop. It's not always by force to do it with a for loop, but the most safest way is to use the for loop because it's a counter control loop. Okay. It's very convenient to use the for loop for this one. It's very convenient. Yeah. Any other questions? Okay. Let's go on. So here too, same. I only changed the right statement. So let me just proceed with the other one. Okay. Okay. Now here, I just want to find the sum of all the elements in the array. I have it written in a while loop, and I have it also written in a for loop. So same thing. Okay, you can see the code, same code. Okay, same code. So, and what do? We start from 0. We always start from 0. And then because the size of the loop is 10, I need to make sure that I end at 9. Okay. Then what do? You do sales plus, sum plus the current sales. So whatever is in sales, maybe with 0. And then maybe the next one, this will change. Sorry. So the next one, this will change. This will change to 1, to 2, to 3, to 4, and all the time, all the way to 9. Okay. Then you can also, so I'm just having so many examples. I'm putting so many examples here just to show you how to do certain things, but it's not by force. Okay. These are just examples I'm putting in there just to reinforce the idea. Okay. That's why I'm skipping some of them. Then some of them are just examples just to show you how things are done. Okay. So for instance, this one, we are finding the largest element of an array. So maybe you have an array of maybe 5 elements. Okay. You have 2, you have 8, you have 4, you have 0, and then you have 7. Okay. So what I simply do is that I create this, you create this variable set to 0, and then we start the index from here. Then we compare this one against this one. Okay. So so this one we set to max, and then we set itself to, we set the 0 to index. Then if we compare, if we compare to, if 2 is less than maybe the next one, okay, it means this one is the biggest. Okay, so we need to make sure that sales is pointing to number 1. Okay, so 2, 8, 5, 7, 1. Okay, so for example, if we compare 2 is less than 8, that means 2 is the biggest. Okay, sorry, 8 is the biggest. Remember, this is index 0, index 1, index 2, index 3, index 4. Okay, so we need to simply make this one, check if this one is bigger than this one, then set this one. So we know that now sales for the max should be equal to the one for the 8. So it's equal to what? Max is equal to 2. Okay. Then we go to the next one and we compare against 5. Then we go to the next one, we compare against 7. Next one, compare against 1. At the end of the day, sales at max is the one that is at position 2. Okay. Same thing occurs over here. And then we have the same thing occurring over here as well. Now, when you are writing loops, it's important to, when you are writing arrays, it's important to understand this very important issue, the issue of array out of bounds. So for example, you create an array of 5 things, okay? 1, 2, 3, okay. 7, 9, 4, 3, and 10, okay? This is index 1, index 0, index 1, index 2, index 3, and index 4. Now you know that, the first index is 0, last one is 4. So for example, if this array is called num, and you are calling num at position 2, you know you are going to get the item 4. But somebody will forget and call num at position 5. Notice that there's no position 5 over here, or there's no index 5 over here. So this one, what is the computer supposed to do? This is the issue we call array out of bounds. When you try to use a number which is not part of the acceptable index in an array, we call that idea or that violation array out of bounds index. Okay, so please take note of that. Sometimes it can happen. It can happen that you use a number which is far beyond or far above the expected that you are supposed to use. Okay, so please take note of that. Okay, any questions? You should not forget, or you should not create arrays which are bigger than the size that you have indicated. If you have indicated that the size of your array is 5, what it means is that because you start counting from 0, the last number is 4. The last number is not 5. So don't go and call array at position 5. Okay, don't do that. It's a very terrible idea. Okay. 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 So an example is seen over here. In this example, we create an array called items. So items is an array which contains 5 things, 5 positions. Now, we are starting from index at 0, and we should end at index at 5. But notice over here, the second index is 1, third is 2, fourth is 3, and then finally the fifth one is 4. So where from this 5? So notice that it is the programmer who is causing the problem, because the last index is 4 and you want the thing to end at 5. Where would the computer get the fifth one from? Since you are the programmer and you created the array. Okay, so because you are the programmer and you created the array, you are not allowed to call the array more than the size of the array. Okay. Any questions? Hello, are we there?
Yes, sir.
Yes, sir.
Yes, sir.
So you're okay with that? We are okay, right? No questions? Okay, since nobody's answering, let me proceed. Okay, now you are allowed to partially fill the array. Okay, you are allowed to partially, when we say partially fill the array, what we mean is that you can choose to have some of the elements in the array there, or all the elements there. When we were starting, I told you that you can declare an array. Maybe let's declare an array called X, and then let's put in 1, 5, 8. Okay, so what it means is that X contains 3 things: 1, 5, 1, 5, and 8. This is X. Position 0 is 1. Position 1 is 5, and then position 2 is 8. Now, you can declare an array and fill it to the brim, or fill it full with all the things, all the values you need. You can also decide to create an array or declare an array which is not totally full. Okay, so here we create an array called items, which is supposed to contain 10 members, but we only put 4 of them there. We can do that. You are allowed to only put 4 of them there, or 2 of them there, or 3 of them there, or 1, or even none there. Okay, but make sure that you don't call the computer to go and print whatever is inside. It is not going to be possible. Okay, So here we create an array of 3 or 4 numbers, and we put 3 in the first position, we put 5 in second position, we put 9 in third position, we put 7 in fourth position. Notice that the others are empty or are filled with zeros. Okay, so please take note of that. Now, you can also have a case, for example, like databases, where the computer is using arrays to store multiple data which are related. So, for example, if you are going to the bank, okay, you can have maybe a bank account related with the bank balance, related with maybe the account name, maybe account address, and so on and so forth. Consider that when we say array is a collection data structure, which consists of item sets of the same type with the same name, what it means is that I cannot mix the phone number with the name of the person. Okay, name and phone number are 2 different data types. Amount and name are 2 different data types. You cannot put amount inside phone number. Neither can you put name inside amount. So basically what you do is to, what you would do is to create a data, a collection data structure, or you create 2 arrays, one for data type, one for the name of the person, and the one for the amount of any of the people that you are storing. Okay, so most of us on our phones, we have a phone book, and the phone book will have a name and then contact number. So name is a string, and maybe contact number is an integer, but every name has a related contact number. Okay, so that's what I want to just relate to it. So for example, this one is called name, and then I have Kwame, and then I have Kofi, then I have Ama. Okay, then I have another array. So I have amount, and amount I have created 3 things. So I have maybe 13.5, I have 4.8, and I have 41.92. So what it means basically is that these 2 are related because Kwame's amount may be 13.5, Kofi's amount may be 4.8, and then Ame's amount may be 41.9. Notice that the sizes are also the same. Okay, so parallel arrays, the sizes are the same, and the data is related. There's a relationship between the data. So please take note of that. Now let's look at an example. So in this example, we have an array called name. It has 5 items. An array called age. It has 5 items. Then I have the values in the array. Then I have the values in this array. So now what it means is that age of Yao is what? 12. The age of Kweku is 20. The age of Pete is 18. The age of Akosia is 14. And finally, the age of Efia is 16. That's what this means. Okay, you can see the relationship between them. Okay, you can see the relationship between them. Okay, and finally, this one. So when you use the for loop, what will be changing is the index at that position. Remember, this is position 0, position 1, position 2, position 3, position 4. You see the change? The change is the index. So you call the name of the array, and then you put the counter variable that you want it to change to over there. Okay, another example here, we are trying to find the maximum sales. We have lots of sales and we are choosing the maximum sales. So in order to choose the maximum sales, we need to sift through the sales and then find the maximum sales. So how do we get the maximum sales? We collect the sales, we input your name and collect the sales. And then if your name is star, we stop. But if your name is not star, then we check if the sales we are currently holding is more than the maximum. If it is, we set the index and then we set the max equal to the sales at that particular index. Then we continue and then we collect and then we continue. We do it several times. When we are done, we print the maximum sales and then we print the name of the salesperson who had the maximum sales. Okay. Now we can also have a matrix of values or of data. Okay. In programming, we call this kind of thing a matrix. I believe most of us learned about some of this thing in primary and basic school, or I think GSS or something. Okay. So a two-dimensional array is no other thing than a matrix in programming, right? So here, two-dimensional arrays, remember we have rows, and then these sides are the columns, okay? Now, in order to differentiate between them, in order to differentiate which one is the first one, second one, and the rest, we give them index. So the index are based on the position of the row with the position of the column. So this one is 0, 0. This is 0, 1. This is 0. Remember, we are on row 0. So there's 0, 2, row 0, column 3. Then here we are on row 1. Okay. So sorry, row 1, column 1. Sorry, column 0. Okay. Row 1, column 1. Row 1, column 2. Row 1, column 3. Then we are currently on row 2. So row 2, column 0, row 2, column 1, row 2, column 2, and then row 2, column 3. Then over here, we are on row 3, column 0, row 3, column 1, row 3, column 2, row 3, column 3. Okay, so we find the position using the intersection of the row and the column of the particular data type. Oh, sorry, a particular two-dimensional array. How do we even create a two-dimensional array? You simply write declare, and then you write the name of the data type of the array. So maybe integer, maybe the type is the name of the array is called amount, and then you indicate the row size and the column size. Maybe the row size is maybe 2, maybe column size is maybe 3. So you indicate the row size and column size. Okay. Now you can simply do this easily, like I said earlier, by writing the declare keyword, writing the data type, the array name, and the row size and column size. Okay, so an example, if I want to declare an array called amount, the data type of amount is what? Maybe decimals. Then I'll write maybe declare. The decimals is what? Float, and then is amount, and then because it's two-dimensional, I'll write the size of the array, so the size of the row, and then the size of the column. Another example would be to write declare, and then maybe I write string, and then let me write name, and then maybe the size is maybe 100, and the size maybe 100. Okay, so number of rows is 100, number of columns is 100. Any questions about the two-dimensional variable declaration? Any questions?
Yeah, sir. Hello, sir.
I'm here. I'm still here.
Okay. Looking at the two-dimensional arrays, can we say is it the same way the Excel sheet does
Yes,
the
yes, 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 yes.
calculations?
So I did say, if you remember, I did say that look at the way the Excel, the row and the
yes.
column addresses work.
Yes.
That's the same way. Excel takes that idea from here, okay?
Okay.
From programming, okay?
Okay.
Uh-huh.
I get you.
Okay, so that's, if you see how an Excel sheet looks like, that's the idea.
Yeah, and even when you are writing Excel formulas, assume, let's say you want to calculate values in maybe 2 or more cells. When you enter the equal to and you give the name of the cells, let's say A2 plus A3, then Excel use the values within those cells to perform the calculation.
Yes, something like that. Yeah. But here we are going to do programming itself.
Okay.
So that's basically it. Okay.
Thank you.
You're welcome, sir. Any other question? That's a good question. Okay, thank you for asking your very relevant question. Any other question? Yes, any other? Okay, whilst we wait for your questions. So if you want to put items into an array, so we created an array called items, and then the size of this array is 4 by 4. It means there are 4 rows. 4 rows. We are starting from 0 all the way to 3. That's 4 items, and then there are 4 columns. Remember, this side is the rows, and then this side is the columns. Those of us who went to Saito, no, we normally would rather give the columns the names rows, right? But it's not so. Okay, so columns here, rows on that side. Now we are putting, so look at the rows. So this is a row 0. This is row 1. This is row 2. Okay, and then finally row 3. Remember, because we start counting from 0. Okay, so because we start counting from 0, this is the first one. Okay, so we put them in like this. Now notice that this is column 1, column 2, column 3, column 4. That's column 0, column 1, column 2, column 3. Okay, row 1. So look at row 1. That's the second row. Column 0, column 1, column 2, column 3. Then row 2, that's the third row. Column 0, column 1, column 2, column 3. So you find that down here like that. Okay. So 0, 1, 2, 3. Then finally, row 3, which is the fourth row, 0, 1, 2, 3. So you can see row 3, fourth row, 0, 1, 2, 3. So that's basically how the computer sees this kind of stuff. Any questions? Okay, no questions. Let's proceed. Okay, now let's look at how to access. If I have things inside, if I have an array, a two-dimensional array. Okay, let's go back to the. Okay, and then let's do whiteboards. I hope you can still see my screen. Okay.
Yes, sir.
Please, do not write on the whiteboard, okay? Don't write on the whiteboard. I'm begging you, don't write on it, okay? Some people are in the habit of writing on it. Allow me to use teach a bit, okay? Okay, now, assuming that we have Okay, assuming that we have created a two-dimensional array with an integer called max, okay? And then maybe we have 10 rows and then maybe 2 columns, okay? And then maybe we created position 0, position 0. We put this, okay, let's say this is too much, so let me I want to reduce the size a little bit, okay, so that we can put something there, okay. So let's say maybe 3, okay. So 0, 0, let's put 15, max at 0, 1, let's put 10, max at 1, 0, let's put 9, 19, okay. Max at 1, 1, let's put 18. Max at 2, 0, we put 12. And then max at 2, 1, we put 13. Okay. So here what it means is that we have an array of 3 rows, row 0, row 1, row 2, and then the columns are 2. So column 0 and column 1. At position 0, 0, which is this one, intersection of 0 and 0, here we have the number 15. At position 0 and 1, so 0 and 1, we have the number 10. At position 1 and 0, so 1 and 0, we have the number 19. At position 1 and 1, so 1 and 1, we have the number 8. Position 2 and 0, 2 and 0, we have the number 12. And at position 2 and 1, we have the number 13, so 2 and 1. So it's just like Excel. You just look at the rows first and then the columns next. Now, if you want to see what is in a particular position, maybe you do right, and then you want to see what is at position maybe 0 and 1, okay? Now, what will happen is that the computer will look at position 0. So position 0, remember, the row is always the first one. So row, so this one's, so this ones are, I'm still doing the black. Okay, so this ones are position 0, okay, for row. And then for column, the 1 is this one. So the intersection of the 2 of these 2 things, this one, is what will be returned as the answer over here. Okay, are we okay? Any questions? Do you see my slide? Any question? Or do you see the whiteboard? Any question? Hello?
Yes, sir, we can see it.
Okay, but you're okay with the explanation, right?
Yes, yes, please.
Yes, sir.
Okay, let's go back to the slideshow. Okay, now that we are back to the slideshow, let's finish it off by finish off the lecture by looking at how we can now access the members of an array. So if you want to initialize two-dimensional, you can also do it like what we saw earlier, okay? So you can check the things in an array with the column index and the row index. If you want to put things inside, you can just put things inside by maybe specifying the column and the row index. So maybe over here, we want to put the number 15.50 into the position 25. How do you do it? You write the name of the array and then the position that you want to put that number, and then make sure you put the assignment operator in between them. This will force the array to put that into that particular position. Okay. Okay. Now, how do you let your array go through multi-dimensional things? Okay. So for example, you have an array which is 2-dimensional and you want to print everything inside that array. How do you print everything inside that array? In order to print everything inside, because your array is 2-dimensional. Remember, the array is 2-dimensional. It has both columns and rows. Okay. So you need a way to run through the rows first, and then you proceed to the columns. So how do you do that? You use what we call a nested loop. Okay, so nested loop means that there is an outer loop and then there's an inner loop. The outer loop will take care of the rows. You should always start from 0 and end at the size of the row. Okay, so end at the size. Okay, then and make sure you increase +1 +1 +1. Okay, then the inner loop should also control the columns. Make sure you start also from 0 and end at the size, and that one to make sure that it is what? +1 +1 +1. If you are writing a while loop, it will look the same. Okay, remember while loop, these two things will be outside over here. Then the test condition will be inside over here. Okay, these ones are the test conditions. This is the initialization. Okay, 2 of them. Then the updates are down here. Okay, so the updates are down here. Okay, is it understood? I have so many markings on it. Okay, or you guys will take your time and then maybe watch the video, or maybe take your time and go through. The way you're not asking questions, I'm a little concerned, but I take it that everything is okay for now.
Yes, sir.
Okay. So you can do the same. If you have, the moment you have a 2-dimensional array, you should always use 2 for loops. One to handle the row, the second one to handle the columns. Okay, so that's basically it. So if you want to even do inputs, it's just a matter of writing what? Inputs. And this will allow you to enter something into all the positions. To start from 0, 0, then 0, 1, and 0, 2, and 0, 3, all the way to the end, then 1, 0, then 1, 1, 1, 2, all the way to the end, and then to continue to the end of the loop. Okay. So over here, we are printing all the items inside the loop. Remember, row size is a variable which contains an actual number. Maybe if row size is maybe 10, and then column size maybe also 10, it means we are running from 0 all the way to 9, and from 0 all the way to 9. So in the end, we'll have 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9. Then we'll have 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, all the way to 1, 9. Oh, sorry, yeah, 1, 9. Then the next one will have what? 2, 0, 2, 1, 2, 2, all the way to what? 2, 9. And then we'll go again till we get 9, 9. Okay, so please take note of that. Okay, so same, I think it's the same thing. I just use different, just to show you that you can use 2 for loops for. Now, what are some of the major advantages or disadvantages for using arrays in your programming. So in your programming, if you use arrays, what are some of the advantages? One of the advantages, or one of the key advantages of using loops in your programming is that if you use loops, then you can access the elements directly using their index. Remember, whether it's two-dimensional or one-dimensional loop, we can easily access the elements or the items inside the array using the loops, using the index. All you need to do is to write the name of the array and then write the index of the array. As soon as you do this, the item will come, okay, or the value that you have in that particular position will come. So loops are very easy. You can just return the item very quickly, okay? Instead of creating 100 variables and then memorizing which one has the thing you want, and you can simply use loops to do that. And arrays to do that, Arrays can also store data in what we call contiguous memory locations. What it means is that when you store, or when you ask an array to hold the information, we store it in empty spaces which are close to each other. That's what we mean by contiguous memory locations, okay? Then arrays are useful for multi-dimensional data. So multi-dimensional data. Multi-dimensional data here means that we have what 2 dimensions, 3 dimensions, 4 dimensions. The example we just saw with the 2 for loops is 2 dimensions, okay? Okay. So that's what you can do with loops. Now, they can easily be used with loops and functions to reduce repeating yourself, okay? Instead of creating, maybe you have to deal with maybe 1,000 variables. Instead of creating 1,000 variables by hand, you can simply write one line, okay? You can simply do declare, maybe int, maybe item, and then write 1,000. This is all you need to create 1,000 item array. But if you don't do this one and you want to do variables, you have to write 1,000 lines of declare int 1. Sorry, declare int item 1, declare int item 2, declare int item 3, declare int item 4. You see that that's very inefficient way of doing things. You can do it like that too, but it's very inefficient. It's not the best way to do things. Okay, so you should not do that. And then arrays also have what we call a low overhead. The computer doesn't struggle when it's working with arrays because arrays are very simple to deploy. And then arrays serve as foundational structures for implementing other data structures. So in the future, when you do data structures, you learn about how arrays are used to do things like stacks and queues and the rest. Then arrays are also compatible with most programming languages and most computer hardware. Okay, arrays are very easy and very compatible with those kinds of things. So it's very important. Now, the disadvantage is that as for arrays, if you decide to use them, you must know the size before you create them. Because arrays, that's the only way you can create an array. You have to know the size before you create the array. It's very important. And then you can also allocate, because they allocate memory to arrays. If you create maybe an array of 1,000 items and you only use 100, the rest of the 900 are basically useless, okay? But the computer will not reuse those 900 until you decide to destroy the 900, okay? So the entire 1,000, okay? So once you apportion memory for an array, the part or the memory required for storing that array is held on until you close the program or until you end the program, okay? Then only one type of data is acceptable. So arrays, you can't mix the data type. You can't say that, okay, I'll create an array where I'll store people's names and their phone numbers and their age. No. You can create one array for phone number, plenty phone numbers, one array for plenty names, one array for plenty ages. But there's no one array that can store phone number and name and age. So you can't mix data types together. Then sometimes some of the operations like insertion and deletion are not the best. In arrays, in fact, arrays, you can't, once you create the size, you can't delete. It's important to understand that. So all of that memory is held on until you decide to destroy the program. Okay. And then arrays have no way of checking whether you, the programmer, are writing code which is causing the array to go out of bounds. For example, if you declare an array which has a size of 10, and in the future you go and call the position 12, notice that there's no way the computer can find the position 12 because this array, the last number is 9. So if you go and call 12, how would the computer check for 12? Because there's no 12. But arrays, particularly the ones like, for example, in C, don't have a way to tell you that you shouldn't do this. Instead, they will allow you to do it, and if there are any consequences, you will suffer the consequences. Okay, so you should not play around with arrays at all. You should know exactly what you are doing before you do them. Okay, then sometimes large arrays can take up a lot of memory and can cause the computer to keep running without stopping. Okay, then there's a lack of flexibility as well compared with some other data structures. Okay, so arrays, unlike other data structures, there's no flexibility with regards to how they are used. Now, since this is the last slide, I'll leave room for some questions, and then if you have any questions concerning the arrays, we can answer or respond to them. And then if there are no other, then we call it a day so that you can go on and rest more for your next class. Yes, any questions?
Yeah, sir.
Yes, sir.
Yeah, this is Richmond. Yeah, I wrote the question down, but it looks as if.
Oh no! Oh, sorry. When I'm here, when I'm on the slide, I can't read.
No,
the question, please?
not the chat. I wrote it on a piece of paper. But
okay.
Yeah, but the first point under the disadvantages, the size is determined at creation and cannot be changed during the runtime. So
yes,
I want to find out as a programmer, if let me say if I ask you to advise us at what's the best size that one has to go for when creating the arrays. Thank you.
Oh, no. It depends on the thing you are building. If the thing you are building requires 20 spaces, you need to create an array that can store 20 things. Okay? So it's not about the best size, but there are other data structures. In fact, there are other ones apart from arrays. Oh. But for this course and for your beginner's course in programming, we are going to learn arrays. Arrays are not the only way we can store large things. Okay? We can store there are lots of different ways we can store large things.
Okay, my last question has to do with the multi-dimensional. I don't know if you can.
Oh, multi-dimensional is the one I said. For example, if you have more than one dimension. Okay, so maybe it's something like this. This is 2-dimensional, so it's multi-dimensional.
Okay.
Okay. So you see, this one requires 2 for loops. One loop to control the row, and a second one to control the column. So just imagine this was 1,000. This was maybe 1,000. Yeah, that's a lot of operations.
Yeah.
Okay. So if there are even more, then you can get a lot more operations, and that means your computer will be very, very, very constrained. It will run. It will not stop. Okay. To consume a lot of memory. Yeah.
Thank you.
Okay. Yes. Any other question? Okay. In the absence of any question, then we'll end the class over here so you can rest. And I think you have another class after this class, right?
Yes, sir.
Yes,
The other
Okay.
class.
So, pardon?
The other class is 3.
Oh yeah, I know. I said one, but we can't just stay here and you not ask me any question. And also, I can't also be here like that, or you want to just be here like that. Okay, so we just have one more of the lessons to do. When we finish that one lesson, we will use the face-to-face that we meet on campus to go through everything and prepare ourselves for exams. Okay?
Okay,
Yes,
sir.
sir.
Okay,
Yeah.
sir.
So please try and come for the face-to-face. It's very important. Okay, especially for my class.
Okay, sir.
Okay, and bring my assignment. Don't come and give
Okay,
me
sir.
excuses. Find a way to get the assignment.
Which
to the
assignment?
course rep. Okay, yes, the assignment. Yeah. Find a way to get the assignment to the course rep.
Okay, sir. We'll do that.
Yeah, it's very important. If you have tried everything and you still can't come, then find a way that you and your team member can come. But I don't think there will be a team that both people will not come. Okay, so enjoy the rest of the day. Thank you very much. Thank you.